4.
4. Cool. Why?
Because we can. It could be fun.
Because we can,
Give us
and we
plus
can't
and
use any
zero.
other rules.
Yeah.
So we can use that one. Okay, I'm just going to group them to probably see what is it that I've seen, which is these two are the plus rules, these two are the times rules, these two are just number rules. This is the 0 rule, that's the 0 rule, that's the 0 rule in each case. If you're counting, you've got a 0 rule and a non-zero rule. If you're adding, you've got a 0 rule and a non-zero rule. If you're timesing, multiplying, you've got a 0 rule and a non-zero rule. We're adding a non-zero number, that will be the rule 4. Okay, so that says we've got an x and an s of y, so I'm just underlining x and y, and that's going to be equal to s of x plus y by Q4. So someone else, what's our next move? Pick a number between 1 and 7. 3? Cool, why? Yep, it's a plus and 0, right? Yep, good. So plus, so 0, so number plus 0 is equal to that number. Yep. So that's what the rule says. By Q3. And now the successor of 0 is written the same with or without brackets. So that's just the same thing again. You could just cross this line out and say this is that line. If you like to write it with the brackets and without, I sometimes find it easy to follow all the steps. That's just the same line as above. Okay, so now we've shown that 1 plus 1 equals 2. We're on a roll.
Can you do like instead of as bracket SO plus 0, can you just do SSO times SO? Because 1 plus 1 equals 2, right? You can also do 2 times 1 equals 2.
We could do 2 times 1 equals 2. We're trying to get from 1 plus 1 to 2. So we could do that proof, but I don't think we need it for this proof.
Oh, okay.
We're just trying to get from that goal to here. But what was it, 2 times 1 equals 2? Was that the claim?
Yeah.
Does anyone believe this claim? Sounds like they just believe, let's prove it. Okay, so what are we claiming? We're claiming the ridiculous idea that 2 times 1 equals 2. It's true, so you're safe, but it's also plainly ridiculous, so we need to prove it to convince ourselves. Okay, so 2 times 1, good move. If you've got 1 times 2, it would be much longer. Okay, so 2 times 1 equals 2. That's our claim. I'll give you guys a head start. This is 2 times 1 equals 2. I'll give you guys a head start. That's an equals, so we're going to do an equals block. We're going to use these rules. I'll give you a chance to play, and then I'll join you. Please don't prove a contradiction using this, because then 2 times 1 won't be 2. That will be disturbing. Yeah, I know. These are simple answers, so hopefully they will turn out okay. We're introducing algebra in the second hour. Okay. Right. Giant reasoning block, SSO times SO equals SSO, block 2. That's an assignment introduction. Multiplication by non-zero number, so I'm using the Q4. Multiplication by 0, I'm using Q3. So I just followed the patterns of what was being done. In this case, it was reasonably straightforward. There weren't multiple patterns. Multiplying by non-zero, which is Q4. That would be multiplying by a 0, which is Q3. That would be adding by a 0, which is Q1. And that gave me the answer I was looking for. So in the simple cases, you just can do the patterns, break it down. If you're trying to get to a single whole number, you can generally do that quite easily. If you're trying to do something like 1 plus 1 equals 2 times 1, then you have a bit more wiggling to do in the middle. Unless you want to prove they're both 2. Okay. So you can see that came pretty quickly for me with practice. Without practice, it's slow and painstaking you to practice it. But in the exam, I'll expect you to be able to work that out as fast as I did. Just a minute to prove 2 times 1 equals 2. Just filling those lines, that's that. The harder, longer ones get slower. Okay. So we've kind of got the hang of that, and we're getting there before I rudely interrupted and wrote it on the board. Good. Yeah. No, I'm not. Have I made a mistake?
It's actually Q6.
Oh, I'm out by 2. We're at -2 equals 0. Okay, so that's fixed the rule there. We'll just add 2 to all of those. Right? 6, 5, and 3. Good. Oops. Okay. So we're going to be moving on to doing things like for all x, x times 1 equals x. Those are the sorts of directions we're heading in. Or for all x times 2 is bigger than x, or something like that. But I just want to make sure people have got this solid idea of how to add and how to multiply, because we're doing very small cases to start with. So we're using these kind of big concepts and big complicated rules. But the big complicated rules as they're written are reasonably small operations, and you're pattern matching like we were in weeks 8 and weeks 9. So who wants another simple example, just to make sure people are solid? Couple? Okay. Someone want to make a simple mathematical claim and we'll try to prove it? Like the bold claim that 2 times 1 equals 2 that we just had? Who's next to the bold claim?
2 times 2 is 4.
2 times 2 equals 4. Ooh, this could take a while. Okay. How about 2 times 2 equals 3 plus 1? Because that's doing the plus and the times. Okay. Right. So 2 times 2 equals 3 plus 1. I'll leave all of that board the same. I'll rub this out, and we'll see if we can fit it on. Right. Okay, let's see. 2 times 2 equals 3 plus 1. Step 1. Now I'm doing step 2, which is above step 1, but my arms aren't long enough, so I'm moving it below step 1. SSO times SSO. SSO plus SO. Step 2. So I'm just going to autopilot this and see where I go. I mean, I know where I'm going to go, but okay, multiplying by a non-zero. So SSO times S of O plus SSO, has to be in that order. That's what you guys call Q6. Okay? It's all good? Multiplying by a non-zero number again, Q6. Notice the order of the brackets matter. I mean, we know that addition, it doesn't matter the order of the brackets, but we haven't proved that. We can't prove that till the end of next week. I think that's one of the extension exercises. So don't rush, keep your brackets organized. Now in the innermost brackets, we're multiplying by 0, so we can simplify there. SSO plus SSO plus 0. We can simplify again. We're adding to 0, adding 0, so which is Q3. So we've reduced 2 times 2 to 2 plus 2. Now that's a start. But 2 plus 2 is not 3 plus 1. When they're not the same sentence. You have to prove that they're equal to each other. So, you might think, well, we'll just use Q4, and we'll just go S of 0 plus S0, like this. That's what Q4 tells us to do. And now, this is something that's very, very tempting. Do not do this. Done! You can't do that. You can only drop brackets when there's no connectors in the middle. So that's one more than 2 plus 1. So that's not necessarily 3 plus 1, because it's one more than the total. We're not just applying the one more to that side. So we have to break it down further. That's successor of the successor of SSO plus 0. We're doing Q4 again. And now we're adding 0 to something. So that's SS0, SS, and those brackets are optional. That's Q3. So now we need to get from that to the other end. Now, there's 2 ways to do this. One, you can work your way upwards. That's a good way to start. The second way is you can use magic. So this is clearly SSSO plus 0 by Q3. Find to add 0 to it. And now by Q4, equals work both ways. I'm going to use that rule, the same rule, in the opposite direction. Can I do that? That's my magic trick. This is the successor of 3, which is the same as the successor of 3 plus 0. That's the move. So that's successor of successor of successor of successor of 0, which is the successor of 3, written the same way. So that's the successor of 3 plus 0. And then this, by Q4, is that line there, because the rule lets you move an S in there in the same way that it lets you move an S out there. The S works both ways, the equals work both ways. Now you might think, what the heck happened with those 2 lines? Let's write them in a slightly different way. I'm going to start with this bottom line at the top. 3 plus 0. So 3 plus 1. I'm going to use Q4 in the normal way. I'm going to move this S out the front. This is the successor of 3 plus 0, which is the successor of 3. So it's exactly the same 2 steps that I wrote here. It's just more natural to work from your way from the bottom upwards. These steps here, which work kind of the normal way, are exactly the same steps I did here. Because A equals B is the same as B equals A, I just flowed the other way. Now if you're confused about that, the best thing to do is to start with the number, work down the formula, work down until you get a number, start with the formula here, work up until you get the number, and you're done. Working from the number back to the other things is a little trickier, it takes more practice. So try to show that 2 times 2 is 4, and that 3 plus 1 equals 4. Then they meet in the middle, and it's all good, they must be equal to each other. But it's quite fun with a bit of practice to go from here, divide them up into the right shape to get to here. You're really just thinking backwards, which of course we're very used to.
Can we just split 2 plus 2 into 1 plus 1 plus 1 plus 1, and then we just change it into 3 plus 1?
Brackets.
Yeah. So
We don't know the associative, we can't rearrange our brackets yet. That, as I said, I think is one of the advanced rules at the end of next week we'll try to prove. So we can't reshuffle brackets. When you were told probably in standard 4, when you're about 10 years old or something, 5th or 6th year, that, not that I used algebra, A plus B plus C is equal to A plus B plus C. Associative doesn't matter how you put the brackets. That's something you were probably told. You probably never proved that. In mathematics, if you did group theory at stage 3, you got to assume that, but you've never had to prove it. Has anyone actually proved associativity in the system? Next week. So if no one's proved it, no one gets to use it.